All right. So as we talked about homeostasis and we talked about the how humans maintain homeostasis, one important requirement is that a living thing has enough energy, right? Has sufficient nutrients so that it can survive and grow and reproduce and so forth. And so in humans, the system that does this is the digestive system. And the digestive system has sort of two tasks. First, it is to take the large molecules that we consume, that we eat, and break them down into smaller molecules. So when you eat something, it's made of large carbohydrates and fats and proteins. Those are large molecules, as we learned in our diffusion activities. Starch is a big molecule. It can't just go through the wall of your intestine into your blood. In order for your body to actually absorb it, it needs to be broken down into the simplest, smallest components, like glucose, proteins into amino acids. Those molecules are small enough that they can go right through the wall of the intestine and into your bloodstream to be circulated around. So the digestive system purpose is to do that, to digest materials and allow them to be absorbed. So when food moves through your digestive system, it does it through this action that's called peristalsis. So your muscular system, like your esophagus, your stomach, your small intestine, large, they're lined with muscle. And those muscles can contract. And food moves along through the digestive system by this contraction of muscles. It's sort of like squeezing a tube of toothpaste to get every last drop out. You squeeze the end and then a little closer to the end, and then you squeeze it forward. That's how our digestive system works. Contracts, pushing food down and through the digestive system. You can see if we were to look inside of a person, you can see the digestive organs, the mouth, the esophagus, stomach, small intestine, large intestine. Those are the main parts. And then there's some other parts which help add digestive enzymes. So digestion begins in the mouth. You actually have enzymes in your saliva. Saliva is not just like water. It's a mixture of liquid as well as some enzymes. And we know enzymes are specific. The enzymes that are in your saliva, they start digesting carbohydrates. Large starches can start to be broken down into simpler sugars in our mouth and using those enzymes. Salivary amylase. If you take like a saltine cracker or something starchy and just keep it in your mouth for a long time and chew it up and keep it there, it'll start to taste sweet after a while as those starches get broken down into sugars. When you swallow whatever it is you ate after you've chewed it up, chewing increases the surface area of the food so that the enzymes have more area to act on so it can be digested. Once you swallow, it goes down your neck into your esophagus. Your esophagus is behind your trachea. What's in front in your neck is your trachea, behind that's the esophagus. It's like this long, and it leads into the stomach. The stomach is kind of like a pouch. So a pouch, it's muscular, it can expand and contract, and this is where proteins start to become digested. The food sits in the stomach for a couple hours to 6 or 7 hours. While it's in there, there's hydrochloric acid, which starts to break down the foods. There's also enzymes which start breaking down the proteins as well. And so the food starts to break down into like a soupy kind of mixture that as materials are digested further and further, could say it becomes less recognizable. So as that food sits in the stomach, it's digested by protease enzymes, which break down proteins. The stomach acid starts to break it down. And eventually, once it's fully digested from the stomach, there's small muscles that open up to allow that digested food to go into the small intestine. The pH of the stomach is really acidic. It's between 1.5 and 2.5 because there's hydrochloric acid that's produced. So you would think that level of acidity might be dangerous, but your stomach has a layer of mucus that protects it from being damaged by that acid. Sometimes that lining, that protective lining breaks down, and the stomach acid starts to actually damage the stomach tissue. And that's what an ulcer is, if you've ever heard of that. No digestion occurs in the esophagus. It's just sort of a transport. And in the stomach, the mixture of enzymes, hydrochloric acid, and so forth, they're called gastric juices. And the main nutrient that's broken down in the stomach are the proteins. A couple things just to talk about with these diagrams. So in our mouth, obviously we have saliva. It's produced by special glands, salivary glands. Some of them are under your tongue. Some are up, tucked inside the back of your throat. And they sort of squirt saliva in your mouth. Have you ever been on your phone and you yawn or something and then you get a little spray of saliva out? That's because you happen to open your mouth right as these salivary glands are spraying saliva into your mouth. And it happens sometimes. Or if you're reading a book, all of a sudden you have a little spray of saliva across the book. When stomach acid, sometimes, so this is esophagus, stomach. There's a muscle here, a sphincter muscle and muscle here that contains everything within the stomach. But sometimes some of this stomach acid can sort of creep up into the esophagus and cause a problem. You know what it's called? Heartburn? Yeah, that's heartburn. So heartburn, it doesn't really have anything to do with your heart. It has to do with stomach acid from your stomach making its way into your esophagus, and it burns. If people have persistent heartburn, they should have it treated because over time the acid can damage your esophagus and cause problems. So typically, I take a medicine every single morning that reduces stomach acid because I get heartburn. If I don't take it, I always have heartburn.
Could it eat through your esophagus?
It can. I mean, it starts damaging it. If it's untreated, I guess it could. What happens is sometimes those damaged areas can be more prone to esophageal cancer or something like that. So typically what they do to diagnose it is they do an endoscope where they put a camera down your throat and they can look at your esophagus and look into your stomach to see if things are healthy or if there's been any damage. Here's an ulcer. You could see these are ulcers. And what those, like I said, those are areas where the lining of the stomach, the mucus, was broken down and they're being damaged by the stomach acid. So
that's what the stomach looks like.
Yeah, that's what the inside of the stomach looks like. It's just kind of, I don't know. It's got lots of ridges in it. It's muscly and it kind of mushes up all the food. You could see that here too. From your stomach, food moves into the small intestine. It's small because it's narrower, but it's really long actually. It's 20 feet long. And as the food makes its way over this 20-foot journey through the small intestine, more enzymes are added to further digest the food. Again, proteases, lipases, enzymes that break down all the different classes of large molecules, further break down the food. And one of those substances that's produced in our body. It's called bile. Bile's produced in the liver, and it's delivered to the gallbladder where it's stored, and then it's squirted into the small intestine a little bit at a time once it's needed. And what it does is it starts breaking down fats. Bile breaks down fats so they can be more easily digested. There's also enzymes made in the pancreas that are sent into the small intestine to break down all sorts of different materials. So the pH of the stomach, remember, is very acidic, like 1.5 to 2.5. Then once the food goes into the small intestine, the environment there is neutral or even a little bit basic. And that's because different chemicals are secreted into the small intestine to neutralize the stomach acid. And the inside of the small intestine, it's not like smooth. It's not just like a hose inside. It has all of these ridges called villi. And these are really important because they vastly increase the surface area for us to absorb nutrients from our food. You could see that inside of these little villi, these projections, we have blood vessels. So this is where nutrients from the foods that were digested can actually go into our blood to be distributed throughout our body. And the blood that leaves our small intestine actually goes first to the liver to be processed before that blood makes its way throughout the body. Then finally, the food moves into the large intestine. The large intestine is large because it's wider. It's actually shorter. It's only about 4 feet long. It comes up the right side of our body, across our body, down our left side, and then out through the rectum. So basically, by the time food has reached the large intestine, it's been pretty much fully digested, and pretty much all of the nutrients from the food have been absorbed into the blood. Okay. So what's left is kind of a mixture of undigested material and water. And so as this food makes its way through the large intestine, sometimes called the colon, water that's in that mixture is reabsorbed and the body can use it again. And so that forms just undigested material called feces. So no digestion actually is happening in the large intestine. It's just reabsorbing water. Sometimes in different conditions, too much water gets reabsorbed, okay? And then that could cause constipation. Other times there's too little water is reabsorbed from that undigested material. That can lead to diarrhea. Different bacteria and different diseases can increase that. But actually, inside of our large intestine, we have a huge colony of bacteria, helpful bacteria called E. coli. They live in our large intestine, and they help break down materials that weren't digested, and they help provide vitamins. And so they're really important. If you ever get some kind of infection and you need to be on antibiotics for a long period of time, one of the side effects is that it could cause like stomach cramping and digestive issues, because those antibiotics that are maybe clearing up your ear infection, well, they also are killing the bacteria that are in your digestive system, beneficial bacteria. And so it can lead to problems with digesting or with those bacteria. So feces makes its way through the large intestine into the colon, and then it's eliminated through the rectum. And that's basically just a mixture of cells that are from our intestine, bacteria, bile, mucus, and undigested material. That's what feces really is. Yeah, it's okay. So there's also this little extension on the large intestine called the appendix. It's like a little pouch. Looks like a little worm hanging off the end of the large intestine. And that serves as a little reservoir of helpful bacteria, so that if we do have to repopulate our large intestine with those bacteria. They come from the appendix. Sometimes it gets infected. Like when I think I was 11 when I got appendicitis and had to have my appendix removed. Sometimes people get that. If it gets infected and actually ruptures, it can spread bacteria all throughout your body. It can be really dangerous. So to diagnose lots of digestive diseases, one way to do that is using a camera. And so an endoscopy is when a person goes to the doctor's office and they put down their throat, basically a camera with a light, and the doctor can sort of control it, put it into the esophagus, go into the stomach, and they can basically see, is there any damage? Are there any problems that are evident from looking at this? A colonoscopy is basically the same thing, but they go in through the rectum and they can see the lower parts of the digestive tract, the large intestine and so forth. This is interesting because this is actually older. I bet there's better versions of this. There's actually now a pill, a large pill that a person could swallow, and it actually has a camera in it and a light, and it goes through the person's digestive tract, and they can get the images from that rather than having to sedate a person, put a camera down their throat. This is sort of, I bet this is an area that is improving with technology as technology improves. So I'm going to show you this video because it allows you to see inside an actual person's digestive system.